Okay, yeah, so just this finished caching, but this is supposed to be not 0 but 1 because we want to have one wedge. Obviously we cannot have our maximum values -1, we have such an object. So yes, just make sure that this is at 1, not 0, just like it was here. I just noticed that in my last video that I said it wrong. Okay, so now let me set up what is cached out as renderables as well, so we can then start moving on to our building asset generation, and then that one is going to be fairly long, and then we're going to go into the fracture workflow and so on and so forth. Okay, so this is the environment secondary. So I have two elements here which we made in here, right? Now this was the RBD, which we are loading in land animated and RBD. So let's do the secondaries, and then the force will go here as well. So environment secondaries are made out of two object level nodes, right? It's the volumes. I think I'm gonna call these renders so I can create land animated renders, land RBD render, RBD land animate render, RBD render. I think it would be better if we keep the changing names at the beginning, and then rest to be fixed variables. Will be easier for filtering, I think. So it would, in this case, this would be RBD land render. So if I use asterisk for land render, I can just get all of these in. Even in this case here, it will be volumes land render. I'm putting everything capital. And it's going to be then dust land render. These are the particles, right? And ideally then it's going to be, which we haven't done yet, but we're gonna split it later on, instances debris land render. Okay, so volumes, let's drop in a file node, most likely file merge. Actually for now it's going to be only one because we only wedge one, but that's an easy fix. So where are they coming from? We cached it out here. So in this case, wedge source is my wedge value. So I'm gonna get the so I'm middle clicking here to resolve. I'm gonna get the actually I can get this like this so it stays within the relative paths. So this is the volumes only. Let's turn this off. Let's turn this off as well because this one is here, right? Volumes. So let's paste the path here. Obviously $os needs to be exactly same as this guy. That means the file name needs to match. And now instead of at wedge source, we're gonna put again our $slice. Okay, and now load it, but there's only one. Oops, so I cannot load number 2 because there's only one. So what happens is usually this is going to error out if it cannot find the second or the first or the second one. So just set that to no geometry. It's going to just find what it can find. It's going to load what it can load, what it can find. So we have the volumes here. Good. Now we can put a little visualizer just so it's a bit more, you know, it's a bit more easier to see. I guess we can put densities up here, another density here. Maybe this is too much, just give it a little shade. Okay, and we can increase the density if needed. Maybe still too dark. It's just so it's not just purely white. There's still no lighting here, but all right, so we have some volumes here now. Obviously not very high res, fairly quick simulations, but we can crank up the resolution if needed. let's see the yeah, it's only 50 million voxels. It's very low res. Well, it's low res, it's fine res for an angle like this, but it's not so much of a high resolution for a camera like this. So this is going to be dependent on what we're making, but this is the workflow regardless. So this is the volumes. Let's turn this off. Let's bring in the dust. So that's cached out as well, and its result is this. Now secondary debris sim. Let's get that path. Let's put a file swap here. File merge, sorry. And we're gonna get the same name again. So this way we can, you know, keep using the we don't have to put random names for file names. So this way we can automate things a bit more efficiently. Okay, so we have some of our particles as well. I remember that we were going to split this to debris, ID, steam debris initial. Was it the particle size or the mass? So let's, these are still, yeah, remember these were VDBs, right? So we need to VDB points, convert. So I guess we could do the VDB convert points, was it? No, yes, this one. Extract those information out, extract points. So, and then we're going to use, I think, the mass here. So basically we need to split these into two objects. So I guess we can use a wrangle here. We can say there's like this grouping object, right? We can say point group on threshold. So if the mass is 2 debris, let's say, right? If the mass is bigger than 1, if the mass is bigger than 1, then you are a rock, not a sand. So the stuff that is scattered on top, so they're still dynamic, but they're heavier, they're not dust. So then we can do something like this, split here, and we can say null dust or sand render. Debris PTC. This goes here. Let's select the group we just created to debris. Okay. Steam debris 24,000. Steam debris initial. Oh, actually, well, I guess we didn't have to. Let's just try that one to see if it does the same thing. Steam debris. Yeah, invert selection. No, I think the mass thing is slightly more smarter. All right, so this is what we're going to render in this network, and we're gonna object merge our debris points into here, later to be debris, to be instanced with another object. So these are our rocks. Sorry, these are our sorry, my bad. This is our okay, so we need to invert this. I made a mistake. Invert selection. This is our sand that we're going to render. This is our debris that we're going to instance. So if I go here, this is our sand, these are rocks. Okay, cool. Let's leave it like this, and then finally we have the volumes. Okay, so basically what I'll do next would be probably render that overnight, but it would be to put this wedge count to how many chunks we had. 1, 2, 3, 4, 5. Yeah, put that back to 5, I think. 1, 2, 3, 4, 5. And then simulate all the other here as well, right? And simulate all these, so you have the full set. All right, cool. So what I'm going to do now is that I'm going to save the scene as it is. Actually, we could probably do a flip book, then finish it up that way. Before maybe doing that, we can also do something like a control switch to create a little test zone, right? Like a test switch. So we can do like, okay, let's do that. Let's put a null. There's a controller object also, but not here. Null. Let's call this test switch. Okay. Gearbox. Edit rendering parameters. So we can do just this one. So I don't want to confuse anybody with any of these, so I'm going to hide these. Invisible. Okay, so it's just like that now, empty. So what I need is to be able to render everything with a toggle. And then if the toggle is on, I want to be able to travel between the wedges. So this is like select wedge, select wedge, apply, activate, testing, initiate, take off. Okay, accept. All right, so this, so how do we make that work? So that needs to basically kick out geometry if it needs. So we can do something like this. So this is my, okay, I'm reading this from out RBD, right? So I'm going to do this here. So let's do something like this. Let's cut this. No, let's not cut this because I think we are referencing this here and there. So let's copy this. Let's paste it in here. Okay, see, I was referencing this somewhere. Start frame. Let's plug that back in to ROM here to there. Okay, and now what I want is let's load. Okay, what if I, because I can do this in a few ways, I can load everything as a packed object with my file merges, and then I can blast away my value. So I can do something like this, right? I can do a blast. I can say keep wedge. Then I can go here, I can go to my control object, select wedge, copy. Okay, these are all little tricks about how to speed up your workflow. It just takes a little to test it out, but once it's done, it should be fairly fast. So now I'm keeping on the one, but this obviously needs to be packed edit. To full geo. So now I have, oh, I just need to unpack it actually. I think that one is just changing the visibility, because this should be okay now like this. I have access to the points, all good. And now I can dictate on which wedge I want to load as well. So if I go here, oh, we need to do that disappear unchosen geometry trick. So was it in here? No, we did that in the optimization for the landing. Yeah, we did that here. Isolate wedges. Let's copy this. Let's go in here. I think that should do. Yes. Okay, Well, we use the same thing basically. Check what's coming in from next, and then just ditch everything else. So it's like so much lighter geometry now to test. And then we can just go, if I want 1, you see it's loading the other one, 2, fairly fast as well. And if I, so then I just need to basically, this needs to be on with a switch, we can do that. So we can say something like this. This loads everything. Okay, then we can put a switch here. 0 is turned off. Activate testing. Oh no, yes, 0 is turned off. Off means it's going to be 0. Okay. Let's check again. Select our guy. Okay, I want to test. It didn't work. Why? Because I pasted the wrong thing. So right click on the button. Go here. Let's paste this. This is not the. This is the wedge number. Okay, cool. So now it should be okay. So I want to test. I want to render. I leave this on. I want to test. I turn this on, and I can switch between the wedges based on the camera. Look there. So basically, this is usually I use for just to make sure that the displacement is working, the motion blur is working, you know, my render passes are working, because I don't want to load in 50 million polygons to evaluate. If things are working, I want to work fast. I want to be an efficient artist. So I spent 1 hour extra at the end of the day. But I think, how am I going to do this? And this is how I work. So so if I need, so end of the day, when I need to, when the deadlines are closing in, I don't have to worry about these things, and I can work as fast as I can, while knowing that it's solid. There will be challenges, of course. The production will be pushing for you know, faster iterations. Sometimes you'll feel like, I don't want, okay, I cannot spend the time now to set it up with RenderMan, and I'll go with Mantra, let's say, just because, you know, it's easier. Try not to do that mistake, please. It's very important to have a solid foundation, to have a smooth ride with difficult shots, especially. This is where you need to put your pressure on top to drive the shots, right? So you get listened to. You need to understand that the production, it's like a little chat now we're having, but production does push for deadlines. Obviously, this is their job, because otherwise we are creative people. As artists, we want to make sure that our work is really pretty. However, that might mean that we can just keep working until it's really, really good. That's, if we keep doing that, we cannot finish the movies as well. So that's why there's a nice balance between these two approaches. All right, after that little talk, let's apply the same procedure for this guy and this guy, and later on, no, this doesn't need to be, because this is inheriting this anyway, so it's fine. Okay, let's do it. Let's go in here. So I just need this. So we don't need to, we're not doing any transform pieces in the volume, so we just need to basically this part. Let's go volumes, paste. So show everything, or show the wedges. Low. So this is gonna be. This could be like density, volume, this and that. So you cannot just load them in. You need to load them packed like this. Then blast away what you don't want. Then unpack it. And if you're going to actually unpack it, probably here, because you can render packed objects, but you cannot manipulate them or visualize them. So this is probably a better approach like this. Let's put a null. Out volume. Okay. Oops. Again. Okay, so then this is still the same thing. Let's put the flag here, the render flag here. Okay, and now the dust will probably go just here. We'll do everything as in the most efficient step as possible. All right, so this is loading in as packed again. This comes here. This has to be unpacked even if it's coming from here. So unpack will happen here because these are VDB points, so we need to process them, right? So here, sand render, all good. All right, so now it's not going to switch to somewhere else because we don't have it, but if I turn this off, it's going to load everything, and also loaded this section. Which one is this packed? This guy, this guy, this one. This one can be packed as well. Oh, this one can't be packed because we are transforming it. The objects are packed. This is fine. All right. Let's put back our testing on. Okay. Now I'm going to we'll do a flip book of, I don't know, 200 frames, 250 frames, and for the fun of it, let's do something like this. Let's put little boxes to copy. So there are little rocks. Copy the points. Geometry to copy box. What happened? That's funky. Oops. All right, something happened. Houdini crashed. So let me pause and reopen the scene. Okay, I hooked that up wrong, and then it was very upset. It's the yeah, this is again. So the geometry goes to the left, points goes to the right, of course. So this, because at the moment this doesn't have any orient, so it's just using the velocity to do its bidding. But this is not what we want. We're going to change that later on. But this is kind of like what it will be like when we have the rocks. Of course, these are the simulated rocks. What we can do definitely is to have we can definitely have some more stack, like where we are going to have the trees, to have more different objects to, so they are like in between, that are dynamic but they're transformed with the object to have a bit nicer floor, you know, not just some rocks, dynamic rocks, but because this is kind of like actually cool, because it's gonna be nice to have some rocks falling down. Okay, so what I'm gonna do now is do a little play blast to see how this works, how this looks. So let's again start. Let's make it a bit bigger so we can see what's happening. Actually, you know what? Let's do something like this. Let's put a light in this scene. We don't have any lights yet at the moment. Let's start with a regular distant light for now. Later we're going to change those to Redshift lights. A little bit to the center so we can see a bit nicer. There's this option here in miscellaneous, I think. Yeah, I can scale. That's going to make this bigger. It's easier to work with. And then let's go like this, and then let's rotate this guy. Maybe something like this, a little bit like that. And I can probably turn on ambient occlusion. Actually, I think, you know what, the probably the spotlights works better for when it's the viewport visualization. I think spotlights works much better. So I'm gonna move the camera somewhere I like. Let's say like this, and then I can control click spotlight, which is gonna create the camera from the camera view. Then I can go back to my regular object perspective, select the yeah, okay, so it's kind of like, see, it's nicer. We have almost some shadows there as well. If anything, this volume is a bit now, yeah, we even have the shadows from the little boxes, which we can change the settings, you know, if you need to, from, you can click on the D while your mouse is on the, so basically D opens display options, but depends on where the mouse is. If you move the mouse to network, you get the network view display options. If you move the mouse to the viewport, hit D, you get the display options for the viewport, which you can change the resolutions and stuff from here. Okay, let me see now. Nothing is selected, so we can probably play with the density of the volume. So maybe if anything is a bit too dense, I guess. Let's go on actually. Okay. Alright, so let's do a little play blast now. Where are my particles? And my particles are here. Are they not visible or are they to be selected? Let's select them so they're a bit easier to see. Okay, so now I'm gonna make the play blast for 200 frames. Let's call this flipbook. I say play blast sometimes because that's from Maya. I used to use Maya, so I still use Maya. Okay, start, make flipbook, and I'll come back to you after it's finished. Okay, so I did 107 frames. It actually is very useful. It tells what exactly we need to do creatively. But let's play first. Okay, there's a few things wrong with our cache, and we can address those nodes. But I think that will be for another subject. But I'm going to now briefly say what parameters we should be probably changing. But we're not going to recache that because it's, again, creative feedback. Someone might like it, the other person may not. So what I definitely don't like is that I think we should keep getting the emission happening from this edge. We should isolate some of these interfaces here and definitely keep emitting volume from those areas. So kind of like this, but pretty much everywhere. The dissipation is, I think, too short. It dissipates very quickly. I think it should keep its density consistent for a lot longer. So whatever is our dissipation, we should probably multiply that by 0.1, so it's even smaller. I can see nice little details, so I don't think I'm going to change any settings on the turbulence and disturbance. It's like if we had more voxel resolution, I think it will come up to be much nicer. Regarding the particle simulation, I think we can definitely use more speed variation and density, like these masses. Some of these should probably fall a lot faster, some not so much. So which means that because we had a setting, I'm gonna put this on manual, we had a way to actually do that, which was here, landed vect. I think we need to play with this a lot more, and if necessarily increase the advection multiplier value. So you do want to see, like, especially my eye is going there, like when this chunk starts speeding up, I would like these particles to get sucked in faster with the rest. That's where my eye is going. Maybe our advection multiplier is not strong enough at the moment. Anyway, so I think it's gonna, we're just ignoring these instance orientation now because we're gonna randomize those later on. But I think there's a good potential here. It just needs to be worked creatively, of course, but I think it's definitely going to work. Scale, it seems to be selling. The speed and the amount of detail and the objects, I think that's pretty cool. And probably it would be nice to have, when we isolate these areas, and how could we isolate those? It could be probably as simple as blasting away or painting, or we can even go a bit more simplistic, like we have this is the area that is this, that's still the simulation area, right? So this needs to be still emitting a lot more. So I guess we could do Is it in here? Let me quickly check. Let's select this piece. Actually, we can do something like this. This is the outer edge of our simulation zone, right? So this is our simulation zone. So how do we determine that section? If I go like this, so I need to somehow isolate these areas and emit and group them in a way that so I can emit from those edges. So now actually this is not a very simple problem, because how do I do that? So if I go to terrain RBD, and because it's not this outer edge that I know that it's neighboring to my static area, so it's a little bit more difficult than that as far as I can see. But I just thought about something, so let me think a bit more. So right, it's not like I want to edit from this edge, from this edge. I think it's this one. No, it's even here. It's this one. So that's not where I want to emit from, but instead I want to emit from somewhere that is already intact at the first frame, right? So here, if I go here, so I want to emit from there. So let's say, okay, this is actually a good example. Let's say you got a node like this. There's no way. I recently did something. We did something very similar to this actually recently, and I think it worked really good. So it's a topology that may end up change. So I don't want to paint it over and over. So how can I detect these faces? So I know that my topology throughout the simulation is consistent. So I can do something like this. This is my simulation, right? And let's ideally work on the wedged solution version. So I think I'm gonna just copy this whole thing, put it back in here because it's a bit more user friendly. This is not working somehow. Oh, it's the shoot. This is because this is connected to this, which I deleted it. It's fine. Right, okay. So let's figure out how can I get an access to this guy. Simple. Let's go to the last frame because we know that everything is at the bottom of the ocean or the earth at the last frame, right? So let's go here. Let's kill this expression. So we are already here, right? And then let's do something like this. This is already packed. So we need to unpack this. When we unpack it, we probably is going to, then we need another stream here, also unpacked, but at the same geo. So let's put a grid, and those are supposed to be grouped as inside faces at some point as well. Let's hope we preserve some of those. Let's try to see if we can make sense of some of those faces. Okay, so did it remove anything? Yes, it did remove some. Okay, let's go to a little bit easier view. So this did remove some stuff. So what if I do this? So it kind of did. This is concrete fracture, and there is a secondary fracture, I think, inside. Yeah, it's not really helping. Okay, no need. We can do this. So let's put a grid. Let's put a grid right in the dead center of our canyon. Okay. which is something like this, really long. In our scenario, it should be the whole thing. So how big is that? It's this big, right? And let's make sure this guy is on, where is it? Here. Not on ZY, YZ plane. No. ZX. XY. Okay, doesn't matter. We can just rotate it 90 degrees. Okay. And let's make it quite big as well. Okay, so it's better if we stay in, like, because we're going to get to some points, so try to be reasonable. We know that this doesn't change to a certain degree, so let's bring this down a bit more. So something like this is fine, I guess, even further down. Okay, and for testing purposes now, let's make this smaller, because we can wedge this as well, like everything else. Okay, so then let's scatter some points here, and let's do something like this. We can do, so we know that this is one direction is Z, right? So we can do something like this. We can create a normal wrangle, and we can say at n equals, so we know that it's in which axis this? We know that it's in x-axis. Okay, so we can say at n equals 1, 0, 0. Okay, so one pointing that way. Then we can just, now I'm not doing so much of a let's turn off the relax situations. Vex here, we can do this with Vex as well, just getting half of them randomized. Let's just change the seed here, scatter more points, and let's say this one is here, this one is -1. Okay, merge these, and let's ray these now on this frozen frame of the simulation that is at the last frame. Ray points against the collision objects. Okay, so now they are stuck because they're using the normals that are in the object, and they are shot into space and they hit our walls, but we still have points that we don't really care. And how do we get rid of them? On the ray swap, you can turn on point intersection distance, and you're gonna get someone with some attributes with 0. So let's put a wrangle here and say if the distance is 0, go away. If f at dist equals 0, remove point 0, comma at ptnum. Okay. Okay, now we just have to, let's put more points so it's a bit easier to see. Okay, now we kind of have more points, and basically we also don't want anything that is pointing up or down as well, which is actually not that problem, seriously. Maybe here a little bit, not really, no. The next thing we can do is probably, well, that we can now say attribute wrangle, and let's actually also call these points, let's give these points an attribute, because we're going to attribute transfer to the moving, we're gonna attribute transfer this to this mesh, and then we're gonna attribute copy this to the moving piece. So let's call this f at inner edge. Okay, whatever. This one. Then I have my geo here, right? Then what I can do is attribute transfer this inner edge value. Well, honestly, I think even that's not necessary. Can I copy these and then? No, this is fine. This should work. So that's inner edge. Okay, so if I do a color swap on the points here, ramp, inner edge. Okay, that's a bit too much fall off, I guess. Here, just some inside areas. How much? We could even do blast later on. It's fine. Then I can attribute copy this to the moving version, which is now inner edge. And if I do a color swap of the inner edge, now this should work. Yeah, cool. So I can now use this area to emit constantly, or based on a speed or something. So it's, but now we kind of like isolated the edge, right? And now because we know that this is like the area that's going to come apart last, so we can always emit it, and it's gonna, I think it's gonna probably create a bit better flow. So what I can do finally is that I can say, then I can scatter points on this area only using the inner edge value, because I don't care about the consistency anymore. It's just going to pass into the simulation. And now I have points scattered along those edges that I can pass into. I'm going to cut this, go into manual, landscape secondaries. So it needs to pass into here as a source, right? Because this is my cached. It's not okay because we pasted something. Once again, let's paste this here. I needed to load the whole thing. I made a mistake there. I read RBD. This is trying to load in, because it's trying to load in the wedge. Yes, let's run the wedge as well. This once. So it's change land RBD secondary, this one. Cook, click. So it generates the value. Let's dive in here. Okay, we already had this here, so which means we can use the same logic here. Inner wedge, this is the moving part, so we can plug this guy here. Okay, and we can, this is our hero pieces. Now this is our frozen frame, so time shift. Same thing here, last frame 1500, plug this here. It's the same thing, right? Yes. Okay, let's tidy this up a little bit. It got a little convoluted. Okay, so this one, it goes here. Oh, I have two of them. Okay, so I just copy pasted it into this location because it kind of makes more sense. And then I had my in source points coming from debris source here. I need to, I guess, load back a little bit so it's a bit faster, because this was going in, because we had the test area which was much faster. This was going in to volume retries for the Pyro simulation. So now we can bring this guy in as well. However, there was one thing I want to make sure that we're not overdoing it. Therefore, let's see, let me see, this goes here like this, fine. This is fine. Yeah, velocity. So I don't want to emit all the time at the angle. So he's gonna say if length at v is less than, I don't know, 5 meters, remove point, so removes the points, I guess. Length at v at sign, and I guess, let me see. Okay, so it kind of like adds up itself a bit later on, like slowly, poof. And then I guess it slows down towards the end anyway. But we can also probably, yeah, it kind of dies too quickly. So let's do something like this. Let's put a delete swap. So now we're going a bit less procedural. I think we can do something like this. Points, delete by range. So that's like, let's take it like a percentage. It's all gone. Keyframe, set keyframe, and let's say this frame is 100. That's 0. And it starts dying slowly from this frame forward. Okay. And it's gone. So then now we can merge this stream with the rest of the source points, which is calculating now. Don't calculate. Okay. And finally, we said we needed a bit more, less patience. Let's go 25. Okay, I went half. All right. Now this should kind of fill in that gap. So we're gonna have a lot more smoke. Will feel like it's peeling away from the edge. Okay, a bit more density. All right, cool. I'm gonna close this, and you can recache this overnight again, or day, however, whatever time it is, wherever you are, and so we can continue. So the next thing I want to do is save this. Pretty much, this one is now part 3. So this is like the secondaries are finished. So now we can really start with the building, procedural building generation in the next video. So I'm going to stop this one and see you in the next chapter.